Statistics for Business. The course is designed with practical, real-world applications, bridging the gap between theoretical statistics and actionable business insights. The introductory video gives the overview of the key topics and concepts that will be covered throughout this course, Statistics for Business. Statistics is a mathematical discipline focusing on data collection, analysis, interpretation, and presentation, essential for making informed decisions across various fields. Key statistical areas include data collection, presentation, frequency distribution formation, and measures of central tendencies such as mean, median, and mode. Each of these measures serves to describe a data set's center, though their applications vary. The arithmetic mean provides an overall average, the median is ideal for skew data, and the mode highlights the most frequent value. Other averages like the geometric mean and harmonic mean are used for data sets with multiplicative relationships. In practice, statistics play a pivotal role in diverse fields. Healthcare professionals use statistics to track disease trends. Businesses leverage it for consumer insights, and government agencies rely on it for policy making. The tools of statistics like surveys and graphical representations such as bar graphs and histograms make data more accessible, highlighting patterns and informing decisions. However, the discipline also faces limitations. Quality and ethics in data collection and the risk of misinterpretation can impact reliability. Properly applied, statistics helps solve problems, optimize operations, and improve decision-making process across industries. Measures of dispersion describe the spread of data within a data set, helping to understand its variability and consistency. Range provides the simplest measure showing the difference between the highest and lowest values, while standard deviation reveals the average distance of data points from the mean, commonly used to assess volatility in fields like finance. Mean and quartile deviations offer alternative dispersion measures, with quartile deviation especially useful for skewed distributions as it focuses on variability around the median. And coefficient of variation expressing standard deviation as a percentage of the mean allows for comparisons across different data sets. Skewness indicates data symmetry with Pearson's and Bowley's coefficients quantifying this skew, showing whether data lean towards the left or right. In manufacturing, these measures ensure product quality by identifying deviations from standards, enhancing consistency. In healthcare, they assess patient response variability in clinical trials, supporting drug effectiveness and safety assessments. Social sciences and education use skewness and standard deviation to analyze trends, survey biases, and test score distributions, helping to identify performance gaps and behavioral patterns. Economics apply these measures to understand income inequality, which in turn useful for policy making. Overall, dispersion measures improve decision making, quality control, and insights across industries. Correlation and regression analysis are statistical tools used to examine relationships between variables. Correlation measures the degree of association between two variables, indicating if they move in the same or opposite directions. It is represented visually with a scatter diagram and calculated with methods like Carl Pearson's coefficient for linear relationships and Spearman's rank correlation for ordinal data. Coefficient of concurrent deviation provides a simpler, less precise measure of correlation. Regression analysis, on the other hand, predicts the value of one variable based on another, especially useful for linear predictions. Simple regression involves two variables where one serves as the independent variable and the other as the dependent variable. Applications of correlation and regression are extensive. In finance, They are used to predict stock prices and assess risk by analyzing relationships between economic indicators. In healthcare, regression models help predict disease outcomes based on patient characteristics. In marketing, they assess how advertising spending impacts sales, guiding resource allocation. Correlation is valuable in psychology and social sciences to explore relationships such as between stress levels and health. In general, correlation reveals whether a relationship exists, while regression quantifies its supporting informed decision across fields. The time series analysis is a statistical technique used to study data points collected or recorded at specific time intervals, helping to understand trends, patterns, and seasonal variations. The main components of a time series are trend, seasonal variation, cyclical variation, and irregular variation. Various methods such as additive and multiplicative are used to analyze these components. In business forecasting, time series analysis plays a vital role by predicting future trends, allowing businesses to plan effectively. Methods for estimating trends, graphical analysis, semi-average, moving average, and least squares, each useful in identifying underlying trends. For seasonal variations, methods like the simple average help capture periodic fluctuations. Applications of time series analysis are broad. Business forecasting relies on these methods to anticipate sales, demand, and revenue. In economics, index numbers like the Consumer Price Index and Cost of Living Index provide insights into inflation and changes in purchasing power, guiding economic policy and wage adjustments. Retailers use seasonal adjustments to plan inventory, and healthcare organizations analyze time trends in increased incidence for public health planning. Overall, time series analysis is a crucial tool for making data-driven decisions in business, economics, and policy planning. Interpolation is a mathematical technique used to estimate unknown values within a given range of data points. Key methods of interpolation include binomial, Newton's, and Lagrange's methods, each useful for estimating values between known data points, especially in fields where data is limited. In finance, interpolation helps estimate interest rates between two periods, while in engineering, it aids in predicting stress points on materials. Probability is a study of uncertainty defined as a likelihood of an event occurring ranging from 0 that is impossible to 1 that is certain. The addition theorem of probability calculates likelihood of any one of several events occurring, while the multiplication theorem calculates the probability of multiple events occurring together. Applications of probability are vast. In insurance, it assesses risk and sets premiums. In quality control, it predicts defect rates. And in business, it informs decision making and uncertainty. Simple probability problems often use these theorems to solve questions like the likelihood of drawing specific cards from a deck of rolling certain sums with dice. Together, interpolation and probability play essential roles in analysis, prediction, and risk assessment across numerous fields. To conclude, statistics is a vital tool in business, providing the foundation for informed decision making through data-driven insights. It enables businesses to understand trends, measure performance, assess risks, and predict future outcomes with techniques such as descriptive statistics, correlation, regression, time series analysis, and probability. From quality control and market analysis to financial forecasting and consumer behavior studies, statistics equips businesses to make strategic choices, optimize operations, and respond effectively to uncertainty. Mastering statistical methods empowers business professionals to interpret complex data, derive actionable insights, and ultimately drive growth and competitiveness in a data-centric world. In conclusion, This course will help you with the statistical tools and methodologies necessary to make informed business decisions in an increasingly data-driven world. Happy learning!